So today we're going to be talking about navigating the new era of Gen AI. I'm sure everyone has heard this lovely term many a times over the last year or so. But I'd like to talk about my personal experience throughout the past year, along with a bit of history. We'll get into some specifics of like team dynamics and approaching Gen AI projects, and just have a little fun. Feel free to post questions in the chat. I think we've talked about, we'll potentially address them throughout the session if there's some good, opportunities to jump in. And then anything at the end, of course, we can address as well. I may not have the answers. I should say that as well. A little bit about me. So again, Jessica Clark, nice to meet you. I'm a senior data scientist at Stack Overflow. I've been there for about a year and a half. Prior to joining Stack, I was a senior machine learning engineer at Capital One, where I worked on everything from some really robust fraud models to building out machine learning packages and libraries for our engineers. Done a lot of really interesting things in that space. And then prior to joining Capital One, I was actually a consultant in the data science space. So I worked with a lot of different companies on solving different data sciencey type problems. I'll get into some of the specifics as we go through the session. I received my undergrad and graduate degree from VCU, based here in Richmond, Virginia, which is that red star on the map. I studied information systems in undergrad and was still kind of it was a blend of sort of the business and computer science space, and there was just so much information. I wasn't really quite sure where I wanted to head at that point in time, and so I decided to pursue my master's. And right off the bat, started to grow my love for data. In the very beginnings of that program, I had a great mentor who helped me through making the decision to go to decision analytics and like really focusing in that space. So it was a lot of like data mining and statistics and a lot of introduction to what is now data science. At the time, it wasn't, that was just an emerging term. So it's been interesting to kind of be along the journey and see kind of how things have changed and morphed. And then, of course, my two beautiful cats, I had to put them on the slide for a little fun. They are just so near and dear to me. I also have two daughters who are also really near and dear to me, and they probably would be so upset to know that they were on the slide, but they're also a great support system and a lovely partner as well. But yeah, that's just a little bit about me, and let's dig in. So we're going to start with talking about the evolution of generative AI. So that is what Gen AI stands for. Here on this beautiful chart, you can see it kind of broke it into three different colored sections. You also may see on the x-axis the different years, and along the y-axis, the training compute that is needed for all of these dots that are displayed. So the dots represent, we don't have a key, unfortunately, in this chart, so I'm sorry about that, but the dots represent different models that have been trained, and then the orange triangles represent the generative AI models. So this is, as you can imagine, this progression over time of where we kind of started out in the early 1950s all the way to today. And you'll see that there, with those changes in color, there's a couple things that are important to call out here. So with the yellow area, we're looking at just like your traditional machine learning models, I'm sorry. And then as right around the early 2000s, which is actually would be more accurate. So if you imagine that blue line just maybe over to the left a little bit, we kind of enter a deep learning era. So in the early 2000s is when deep learning models were introduced, which came from the premise of neural networks. And What's interesting about this line you see here, this line of fit, is right around 2008, we see a nice spike in the amount of compute and also the progression into this deep learning space. So what happened here? What happened is we were given, or we developed GPUs and lots of them, and the compute power enabled us to try things that we were not able to try before this point in time. And then as you see in the red space, this is also a sort of a turning point in modeling, which was now we have lots of data. So all of these years of, companies and collecting our data, using, the explosion of smartphones and all of that, and collecting all of that data allowed us the opportunity to, with a combination of compute power, data, and then this other thing called backpropagation, which is the ability to train neural networks. That was also a discovery that was important here within this chunk of time. But all of that combined allowed us to enter where we are now, which is this really interesting space of generative AI. You may have heard me kind of discuss a couple different terms up to this point. So I think it might help to sort of understand the breakdown of some of these terms, because they are occasionally used interchangeably across the industry, or you might hear these terms thrown out. And I think it's helpful to see sort of that breakdown of all of the different disciplines. So artificial intelligence is like the all-encompassing term of everything else that exists here. This is just the idea of machines mimicking human behavior. What you don't see here in this picture would be something along the some additional things that maybe don't fall in these buckets, such as maybe like robotics, or you may have heard the term Internet of Things, like watch wearables, things along that nature. So those are additional pieces that would that are not shown, but are kind of in that like outer space of artificial intelligence. Taking one step down, it's funny. This actually reminds me of like those like nesting dolls. When I first saw this, it kind of made me chuckle. But so next down we have machine learning. Machine learning is a subset of AI. This is going to be like all your algorithms that are used to build models. And you may hear terms like supervised learning or unsupervised learning. Those are just different techniques that are used. And they've been around for a long time. Back in the early days of statistical analysis, like we have, you have for supervised learning a labeled data set that you use to do things like predict the next move in the stock market, say, or the price of a house. Then for unsupervised learning, you might have data that's unlabeled, where you're doing sort of like cluster analysis of different things like your maybe customer segmentation, or just making sense of different groupings of data. So that would be sort of like your unsupervised learning space. But these are all just concepts that live within that machine learning area. And then taking one more step down, we have deep learning. All right, deep learning is what we were mentioning earlier when we entered the world of neural networks and everything that exists in that space, where we really do have, you may have heard the term like hidden layers, or black box. It's the that space that exists that we is less clear of how, like, what's happening in there, and it's like more mimicking human brains. I say mimicking. We're still not quite there yet, so don't worry. We're not actually, creating human brains. We're not there yet. And then one step down from that is the generative AI space that we'll be talking about today. And this is taking input and generating some sort of output, and it's just kind of that nicely nested piece in here. So if you hear me talk about these different terms, this will hopefully provide sort of that mental picture of how it all fits together. Um, but let's dig into how Gen AI is being used today. Companies across industries are leveraging Gen AI in many, many different ways. Here, we'll just kind of step through a few different ways that companies are currently leveraging Gen AI, but feel free to throw in the chat any experience that you've had with Gen AI. It's always really neat to hear how people are using it, either personally or professionally. Um, I just learned about a friend's company who developed an intellectual property Gen AI platform for creating patents. So there's just like all sorts of interesting use cases popping up. Here on this list, we'll start at the top with content creation. So that's a very common one, using it to create written content, music, pictures and videos. You may have heard about news agencies that are using it to generate different reports. So, especially you'll see it in like the data heavy topics like sports or financial news and that sort of thing. Next up, we have design assistants. This is also like a very common use case. We have folks using, companies using Gen AI to do things like building their brands or creating marketing materials and that sort of thing, which is here on the next one. Also, social media. It's like a really popular social media tactic. I have another friend who uses GPT to write all of his blogs. Uh, I don't know how I feel about that. It's a little strange, but it's being done. It's being done all around us. Another example, pharmaceutical drug discovery. I think this is really interesting. So this we dig into sort of the different properties of new drugs, the molecular structures, and the ability to combine data that exists across many different databases that are full of like existing drugs and molecular structures, and then kind of combining and twisting different ways to create new drugs that could be effective. So this is a very interesting space, and I think we'll see a lot more as time goes on in this area. It's also used for simulating different trials and such for like clinical trials for um, the space. Another interesting use case is data augmentation. This is actually kind of where all of this is like one of the very first use cases of Gen AI before it became what it is today, which was creating data to run machine learning models on. Now it's being used in so many different ways, whether it's like adding additional labels on top of data that already exists so you can understand better. You may have heard the term knowledge graphs, like being able to build out sort of this um, infrastructure of knowledge, right? And this is a really neat space that could also continue to grow and morph. Virtual assistants. This is a fun one. This is something that I think will also stay pretty prominent. But the thought of like chatbots and just being able to help schedule and do sort of some of those tasks that we all love, right? And um, also just helping us find answers to questions more quickly on different sites, being able to point us to where to go and that sort of thing. So just that the chatbot example. And then finally, in industries like manufacturing or logistics, Gen AI can help predict future failures. So any based on like historical data, where do we see weak points within some of those processes and infrastructures? This is just a breakdown of a few different companies that exist. This is just scratching the surface, though. We all have seen so many pop up from left and right. Down in the bottom right, Anthropic is like a newer company that has emerged through this. Companies like Grammarly, that were around previously are now using Gen AI and all of their browser extensions, all of their products to help with writing. Hugging Face is a great spot to go when you're looking for um, sort of those off-the-shelf models that have already been trained and they've got lots of neat information about how to use them and how they can be applied to different situations. So that's wanted to call that out because it's been really helpful in my career over the past year. NVIDIA, we can tip our hats to NVIDIA for helping us with all of the compute that we need to be able to run all of these very intensive models. Obviously, we have ChatGPT and DALI, our Microsoft offerings for chat and video visuals, and then GitHub Copilot, which is our helping us with code. So Stack Overflow, I mentioned earlier, is where I'm currently working. It's really interesting. When I first joined Stack, I was one of the first data scientists to join the company. This was pre-announcement of ChatGPT. And we were just starting to look at implementing sentence transformers, which is what I was mentioning. We are grabbing from Hugging Face. These are pre-trained transformers that allow natural language processing techniques. So like being able to sift through and understand the semantic capabilities of language and using it for things like searching and matching and all of that. So that was the initial phase. Well, then all of a sudden, ChatGPT shows up on the scene, and we are faced with the new world that we're living in. And you can imagine being at Stack Overflow, there is the imminent, what should we do? Right? Like this was also right in the tails of some of the work we were doing. So it was like a nice progression to jump into this space, but we went all in and started developing all sorts of products and creating these like proof of concepts in many different areas that touch language and could utilize something like generative AI. One of the first things we announced was our Slack integration bot. So this is a Slack chat bot that allows you to play around and ask questions. There's many different features that were baked in, everything from I'm an analyst. How do I take this CSV of data and do X, Y, and Z with it? So many different applications here within the chatbot, but just to have the ability to ask questions in Slack, right where you're working, in your not kind of disrupting your flow of work, has been really helpful, and has been interesting too from an idea generation space as well. So kind of like when you're just getting started with things, using it in a safe, easy to explore space. Some other additional things that we built out, or we're currently building out, one being a search and RAG summarization product. And so RAG stands for Retrieval Augmented Generation. And really all that means is we take the content that already exists on Stack, we bundle it up, we send it over with a prompt and a query, and to the LLM, and then we get a summarized output. So we take all of that information and we deduce it down to how do we answer the question most succinctly, and really just giving the user the output that they're looking for without having to dig too deep. Obviously, we have different segmentations of users on our site, and that is beneficial for some, while some still prefer to really dig deep into the problem. So how do we offer both a summary and sort of that high level overview, along with the deeper, more nuanced approaches and responses for others to still be able to have the opportunity to do both. So that's been a really fun use case of uh, leveraging Gen AI to solve a problem, which is getting information more quickly, but also still keeping true to the brand and um, really keeping the customer's needs at the heart of it. Obviously, it's been um, it's been a fun journey. We're still on it though. So going back to that point of kind of still being on this journey and still trying to wrap our heads around how do we make this successful? I think this is really important from the standpoint of we have lots of companies that it this is a very exciting time, and we have a lot of companies that are trying to just go all in and use this technology. Um, but how do we do it in a way that's sustainable and that meets our users' needs and is a good fit for our company? So something I've been thinking through is how do we make a successful AI product? Um, this may sound extremely obvious, but really starting from square one and making sure that whatever solution you're wanting to build or you're looking to create, are you actually solving a problem with it, right? So, what's your objective, and making sure that you stay um, true to that objective throughout the whole process. Um, Next, this is very important. Do you have the data? So, we have there's been some really interesting progressions throughout that researchers are starting to come forward with, which is we talked about earlier the need for a lot of data, and that's still important. But what's even more critical is making sure that the data that you do have is high quality data. This helps produce the best results. So, um, going back to Stack, we have a lot of really highly curated quality data. How do we find the best, that exists, and how do we identify that, and how do we use that within our modeling? Next, we want to make sure that we are choosing the right models and algorithms and parameters of those models and algorithms. So there's like a lot of tweaking and testing and iterating that's done to be able to hone in on what is the best solution for this problem. If you just peruse Hugging Face, you'll see all the different types of transformers that have been trained on different types of data. How do you know which one to use? This is a very important part of the process. And we'll get into later in the discussion around some of those decisions that you can make if you don't have like a data scientist or a machine learning engineer to help you through some of those problems. I mentioned iterative evaluation. Um, that is something that happens even after you've deployed your model. You continue to iterate, you continue to evaluate, always to make sure that performance is staying steady. You're producing the results that you want to produce, and you're meeting the needs of your objective. So that kind of goes into both the evaluation, deployment, monitoring. That's all sort of packaged together. They're all very important steps, but they sort of work in tandem. And then finally, consider the ethical boundaries. So we have a lot of considerations based on how you're using it and who your customers are. And we'll dig into those a little bit as well. If you don't have a dedicated data scientist on your team, or you don't have a team that you can throw ideas over to, there are still plenty of options. And this is something that we've experienced at Stack with a very small team, heavy on the engineering and um, side of house, not as heavy on the data side of the house. So um, how do we provide like build solutions that utilize some of these technologies? I mentioned the transformers that are pre-trained models. That's a great way. You don't have to build your own LLM in-house. You don't have to create from scratch your own solution. You can use um, cloud provided solutions. There's plenty out there. The machine learning as a service solutions. There's lots of companies that are developing these out of the box solutions that you can use and your team can leverage. And you can kind of get creative. So even if you are looking for maybe not a full service tool, and instead you want to maybe operate off of something that's like a drag and drop capability of like a low code, no code solution, there's those options too. And maybe you're really comfortable coding, but not as comfortable on, well, what algorithm should I use or that sort of thing. That's when you can kind of leverage some of these additional off the shelf models that have a lot of the description of this is a great time to use this model for this use case. And I think what's most important though to keep in mind is that data is at the heart and center of all modeling, and having quality available data is more important than anything else. And so there's such a fundamental piece to the process that entails. And so I just always like to call that out. And going back to um, when I was consulting, a lot of times companies would come forward with, we want to apply data science to this problem, and then we dig in and we realize the data's not available or there, or it's more of a process thing, or we can just apply a simple rules-based engine to this particular scenario and get a great result. So sometimes machine learning isn't the solution. Sometimes Gen AI is not going to solve your problems. And really going back, if it's something that you can do with, uh, if you can solve a problem without using AI, please, that is the direction you should go. If it's more complex, if we start to get into this like greater reasoning space, if we want to implement things like real-time personalization, or we want to, dig into that, then maybe that's more of a case for using AI. So we're currently facing a lot of um, different challenges with using AI today, especially Gen AI. Um, we've experienced them at Stack. It's something that we've been making, it's been a high priority to address. So I'll talk through some of the challenges and then we'll kind of dig into, well, what are some solutions to those challenges? So we all have heard of, inaccurate responses from AI. You may have heard the term hallucinations. I think that's sort of a misnomer, but it's really just not pulling the right information for the right query that's being asked. That right, the output's not matching the input essentially, but it's still an inaccurate response to an answer that someone's looking for, right? So that's an important thing to address. Also, there's heavy bias. So we think about all of the bias that exists in previous documentation around on the internet, essentially. All of the data that was used to train these large language models is full of toxicity, full of biasness. So how do we address that through the process? And there's techniques techniques to do so. Also, lack of understanding. So a lot of these models are really unpredictable. They're not transparent. There's a lot of unknowns. So um, this is sort of a concerning area, especially dependent on how you use it. If it's a customer facing product, for example, this may be concerning. Also, a lack of governance. So how do we, um, when we think of things like intellectual property and copyright, I mean, there's no verifiable data governance on sort of these assets. So there's definitely the EU, the UK. There's been, some bans in certain countries. Even the US is starting to come up with some ways to address some of these issues, but they're not in place right now. So how do you see in the arts industry, especially a lot of these headlines coming up of um, how do we move forward? Who is the owner of who owns the rights of these sort of this output? Oops, I'm sorry. Also fraudulent usage. So you'll see a lot of like deep fakes coming out, a lot of um, misrepresented or misinformation of news, and a lot of this causes a ripple effect, of course, and is outright a little scary, to be honest, in my opinion. So how do we avoid some of like the fraudulent usage that can happen? You also may have heard of the term, and I can't think of the term, but users also can hack these systems. So like the ability to go in and um, prompt inject, that was what I was looking for, into these systems, into these models to make it produce inaccurate results or make it produce toxic results. So this is all like these are examples of fraudulent usage. And then finally, the environmental impact. A lot of studies are starting to come out around, well, how much is it costing to train these models to keep the lights on? And it's very expensive. The amount of electricity that's used, and vendors are looking for ways to reduce the power consumption and leverage renewable resources, et cetera. But it's still very impactful to our environment.
Hey, Jessica.
Yes.
Hey, we had a quick question, and it's related to the challenges. And the question is, what would be a good approach to better control the hallucination process?
That's a great question. So a couple things. There are hallucination detection models. They do there's a few different actually out there. Some address things like simple regex on determining what exists or doesn't exist based on maybe the query that was provided. Another approach, which I mentioned, the retrieval augmented generation, that significantly reduces hallucination. So by providing additional context with the input allows, you're basically saying, pull from this, and it's providing additional reference material for the model to pull from, and that helps tremendously in hallucination. Some of it's not perfect though, and that still exists, and it's something that will continue to exist. I cannot imagine it being a perfect world of not being able to or to 100% address hallucination, unfortunately, when we think about the massive amount of data that is used to train these models. So those are a couple of techniques, and one of the main reasons why we use the retrieval augmented generation at Stack to help reduce some of that.
Awesome, thank you.
No problem. Okay, so this is an example. The AI generated this image of the Pentagon on fire caused this ripple effect that affected the stock market. So this is like a perfect example of someone just creating this fake image that had a really impactful result on a real life scenario. As soon as you can read, there's articles and such on like New York Times on about this scenario. But as soon as it was released that this photo was leaked and it was not real, obviously everything rebounded and we were fine. But you can see as over time goes on and we start getting really good in creating, fake videos. I'm sure you've seen some of these come out. Like it, the ripple effect is going to happen. So this is just one example of many that exist. If you have any examples of things that you've seen on the news, feel free to kind of throw it in the chat and talk about it amongst yourselves. I think it's a very interesting space, and it'll be interesting, especially as we enter like the U.S. elections, how some of these approaches maybe impact things like our election. That's just one area. I'm sure many others will be impacted. So kind of going back to like the mitigation techniques, I mentioned the RAG approach to helping with hallucination detection models that exist that can sit as like additional checkpoints or gatekeepers of what's the input and output. We also have them for toxicity, and so even OpenAI has created, they have their own moderation. It's basically like a toxicity detection model that sits, it's an API that you can hit as well to help make sure that the input and output are safe for users, and they have different levels of determining whether it's maybe like hateful speech or something else that's awful and terrible. And so really like you can even get granular on the types of detection that is happening. There's also a lot of open source models as well, approaches that exist. Obviously, testing is really important. So creating evaluation pipelines, having reusable tests to determine how well your model's performing is really important. There's a lot of different, if you're comparing different models against each other, there's a lot of like leaderboards and such that exist. But really when it comes down to it, you want to have your golden data set that represents the way your users are going to use this particular product that you're building. And that data set is your source of truth, more or less, that you use as sort of a baseline for some of these evaluations that are done. So this is a really important part of the process, and to make sure as you change things, like maybe you change your prompt slightly, or maybe you change the way your the type of data you're pulling in, like whatever it is that you're tweaking within that process, you want to make sure that you are constantly running it through additional tests and evaluation with each change. Documentation is great. So a lot of what we see coming from the AI Act out of the EU and the AI Bill of Rights coming out of the US is really how do we document all of the different scenarios that exist and all of the risks that are associated, so that way if something does happen, you have a plan in place of saying this is how we're going to mitigate. So really it's what are the potential risks, how do we meet those risks, or reduce them as much as possible. So it really comes into like response plans and that sort of thing. There's also the ability to bake in human feedback. So you may have heard the term reinforcement learning human feedback, RLHF. That stands for the ability to continuously train your models based on how users are interacting with them. And so you may see things like thumbs up or thumbs down on a particular output from a model, or like, you query, you search for something and then the output is returned, and then how did you like that output, or did you not like that output? Well, your feedback to those sort of responses is actually a lot of times used to do things like, oh, no one ever likes this output, let's not show this anymore. Or in this list of 3 things, everyone always thumbs up's the third thing. So let's move that to the top of the list. That's called re-ranking. And so this like re-ranking algorithm also can sit as like a tertiary sort of process in your cycle to help create a better experience for your user. Logging and monitoring. So this is just the ability to observe how things are interacting. This goes beyond just, is my system up and running, but more so, is it still performing how it should perform? Are we seeing new things introduced that didn't exist previously? Do we have these extraneous events that are occurring that we didn't account for? So there's lots of different tools out on the market that you can use just off the shelf. You can also obviously build them, but this is an important piece of making sure that you're keeping an eye on how your model's performing, how you're interacting with how your output is being handled. And then finally, obviously data protection and privacy is a huge piece and always will be. And speaking to data professionals, I think we probably all know this one well, but just ensuring that you're not you're meeting all of those requirements. There's a lot in there. I'm not going to unpack. So my question for you all, do you think Gen AI is all hype? This is Gartner's hype cycle. I'm sure you're familiar with this. This is it for AI in 2023. As you can see at the very top of the peak of inflated expectations is Gen AI and foundation models, which go hand in hand. And we are approaching the lovely trough of disillusionment, which is really the space of, does it all go and die, or does it continue? Would love to hear your thoughts on your personal opinion of how you see it in your industry. I think that would be kind of a neat talking point. I think we'll have a few minutes at the end. We can maybe get into that a little bit more. And then finally, there's a few different areas where I personally, and just from like research and discussion and things I've read, where I see AI heading next, probably missing things. So this is just a short list that put together, but I think we'll probably dig more into like industry specific models. And these are just a couple examples of that already exist. So the MedPalm 2 is focused on medical data, Bloomberg financial data. So I can see this with, data that applies to law or other industries, right? So getting really specific with the language that's used in these spaces and the acronyms and just how, and it's really about how all of that fits together. Then multimodality. So this would be incorporating other things beyond text. So I think LLMs are going to become more it's not just language large models. We have, large models based on all of the things we see and all of even, I use the example of like, I got like a stress ball here, it's, there's, how dense is it? What's the shape? What does it look like? The colors, just really, there's so much more than just calling this a stress ball or ball. It gets into how do we define the objects around us and the world around us and our interactions with them, all of the nodes and vertices, and how does it all fit together? So when you think about machines mimicking humans, what are all of the different ways as humans we interact with the world? So I think multimodality is going to be huge in the future. Simulation. So this is actually would be a result of being able to utilize like multimodality models, but really improving autonomous driving. So a lot of what's prohibiting us from really um, taking on this technology at a greater amount is because we there's a lot of flaws in the system. It's not that great. We don't have the ability to run like multiple simulations. Well, now we do. Now with Gen AI, we do have the ability to do some of this with some of the data generation and all of that. So it's I think this is going to really improve over the next short period of time. I think we'll see it in television and movies and the music we listen to. I think the arts are going to be infiltrated. And then finally, I think we're going to all have our own personal bots on our phones. I don't know. This is just why not, right? You have Siri talking to you. What if you could have it in any voice that you would like, not just a few, but you have endless, tones that you can choose from, or that knows based on what you like, scheduling your personal calendars and doing all of that. I think that would be really neat, and I can see that happening. So yeah, that's about it. Thank you so much for listening. Would love to answer any questions or continue the conversation if anyone's interested.